Hi there, my name is Emmy and welcome to the first module of Day 6. I'll be talking to you about the second derivative. Please pause this presentation at any time when you need more time to think about something. The second derivative of a function is simply the derivative of the function. The notations of the second derivative is given by the notations seen here. We find the second derivative by differentiating the first derivative. For example, to find the second derivative of the function x cubed plus 4x squared minus 3x plus 5, first find the derivative of the function which we call the first derivative. This is 3x squared plus 8x minus 3. Differentiate the first derivative to find the second derivative. So the answer is 6x plus 8. Let's consider another example to find the second derivative of y equals to 2x to the power 4 minus x cubed minus x squared plus 2x plus 3. Differentiate once to get the first derivative 8x cubed minus 3x squared minus 2x plus 2. Differentiate once more to get the second derivative 24x squared minus 6x minus 2. Here are some practice questions for you to find the second derivative. Press pause to attempt these questions and then press play to see the answers. Here are the answers. Here are some properties of derivative you should remember. The first derivative is the rate of change of the original function with respect to x. The second derivative is the rate of change of the first derivative with respect to x. If the second derivative is greater than 0, then the first derivative is increasing and the curve is concave up. Here are some examples of concave up curves. Notice that the first derivative is increasing from left to right, and so the second derivative will be greater than 0. A little tip, you can remember the shape of a concave up curve by recalling a smiley face. If the second derivative is less than 0, then the first derivative is decreasing and the curve is concave down. Here are some examples of concave down curves. Notice that this time the first derivative is decreasing from left to right, and so the second derivative will be less than 0. Another little tip for remembering this shape. If you are feeling down, you will most likely have a frown on your face. So concave down means you have a frowny face. If the second derivative is 0, it means that there is a possible point of inflection. A point of inflection is a point where the curve changes concavity. That is, a curve goes from concave down to concave up, or concave up to concave down. Here is an example of a point of inflection. In this example, the curve is concave down on the left of the point of inflection and becomes concave up on the right of the point of inflection.